Hello everyone and welcome to my YouTube channel NN Fabian Chemistry. So today we shall be learning how to determine the limiting and excess reactants in a chemical reaction. So let's get straight to business. Now, in a chemical reaction, the reactants are often added in amounts which are not stoichiometric. One or more of the reactants can be in excess, and so it is not completely used up in the reaction. Now, it is important to note that in any stoichiometric problem, that is in any chemical equation, where the reactants are not mixed in stoichiometric amount, it is important and very essential to determine which reactant is limiting in order to calculate the amount of product which is formed in the chemical reaction. So what is the limiting reagent and what is the excess reagent? Let's take a look at this. So the limiting reagent, also known as limiting reactant or limiting agent in a chemical reaction, is the reactant that is totally consumed when the chemical reaction is completed. It should be noted that the amount of product formed in a chemical reaction is determined by the limiting reagent, because this reagent or the reaction cannot continue without this reagent. Now, what is excess reagent on the other hand? So an excess reagent or excess reactant is a reactant that is present in an excess of the amount that is required to combine with all the limiting reactant. So in a chemical reaction, the excess reactant is always left while the limiting reactant is consumed totally. Let's look at these examples to explain further. So here we have a reaction between calcium carbonate and hydrochloric acid to form calcium chloride, water, and carbon dioxide. So we have some pictures here. The crosses represent the calcium carbonate particles and the circles represent the hydrochloric acid particles. So take a look at this diagram and tell me what you think the limiting reactant is. I'm sure you must have said hydrochloric acid, and that is true. When we look at it, at the end of the reaction here, what is left? We have just the calcium carbonate particles. The hydrochloric acid particles have been completely used up. You can see at the start of the reaction, we have, let's consider these to be moles. 1, 2, 3, 4, 5, 6. We have 6 moles of calcium carbonate and we have 1, 2, 3, 4, 5, 6 moles of hydrochloric acid as well. Now, from the equation, we should notice that for every 1 mole of calcium carbonate that is used, we have 2 moles of hydrochloric acid that is used as well. That is why if we look at it from here, you can see that we move from 6 moles of calcium carbonate to 5. 1, 2, 3, 4, 5. But how many moles of hydrochloric acid do we now have? 1, 2, 3, 4. So when calcium carbonate decreases by 2 moles, so to speak, by 1 mole, I beg your pardon, when calcium carbonate decreases by 1 mole, hydrochloric acid decreases by 2 moles. And that is why when we look at it here, we have 1, 2, 3, 4. But we have just 2 moles of hydrochloric acid. So in this reaction, you can clearly see that the hydrochloric acid is used up completely while the calcium carbonate is still left. So we can therefore conclude for sure that the calcium carbonate is the excess reactant. Excess reactant, while the hydrochloric acid is the limiting reactant. Limiting reactant. Let's look at the second example. Here we have the case of the engine of a car and the fuel. Now let's consider these to be reactants. So we have one of the reactants, let's consider this to be a chemical reaction, and in this we have the engine, that is one of the reactants, and the fuel that we put in the engine as the second reactant. And let's put it as such that the product of this reaction is for the car to move. So car moves. That is the product. So we have these 2 reactants. Now, We notice that in a car, the engine is always present. But what do we need to put in the engine to make the car move? Of course, we need to put fuel. If there is no fuel, the car does not move. When we put fuel inside the engine, the car moves. And I want you to take note that the distance covered by the car depends on the amount of fuel inside. When the fuel gets finished, the car stops moving. So in this case, we can therefore see that the fuel is behaving like the limiting reagent, while the engine of the car is behaving as the excess reagent. The excess reagent is always there. It is still left even after the reaction is complete, while the limiting reagent is completely used up. So here, the fuel is the limiting reagent, while the car engine is the excess reagent. The distance traveled by the car depends on the amount of fuel that we put inside the engine. And when the fuel is completely used up, the car stops moving. So too it applies in a chemical reaction. When the limiting reagent is completely used up, the chemical reaction stops. Okay, let's now look at these examples, how we can determine limiting and excess reagents in a chemical reaction. Let's look at this example. 1.2 grams of magnesium is reacted with a solution of hydrochloric acid containing 2.74 grams of hydrochloric acid, which is the limiting reactant. What mass of the excess reactant was left at the end of the reaction? Now, to answer this question, or to be able to determine the limiting reactant and the excess reactant, we first of all need to calculate the number of moles of each reactant. When we have the number of moles, we go ahead to determine the mole per coefficient ratio. So how do we do it? Now, let's write the balance equation for this reaction. So magnesium reacts with hydrochloric acid. So let's see. Solution magnesium plus hydrochloric acid form magnesium chloride plus hydrogen. Let's balance the equation. So that is the chemical equation for the reaction. Now let's go ahead and calculate the number of moles of the reactants. For the reactants, we have magnesium and hydrochloric acid. So let's calculate the number of moles of each reactant. So here we have, let's put the reactants. We have magnesium, we have hydrochloric acid. So the mass, we're given the masses in the questions. So here we have mass. The mass of magnesium is 1.2 grams. The mass of hydrochloric acid is 2.74 grams. Okay, we have the masses. Let's now calculate the moles. So moles, we know that moles is mass divided by molar mass. The molar mass of magnesium is 24. So here we have mass 1.2 divided by 24. We have 0.05 mole. For hydrochloric acid, we have 2.74 divided by 36.5. Chlorine, the relative atomic mass of chlorine is 35.5. Hydrogen is 1. When you add them up, it gives you 36.5. If you have difficulties calculating relative formula masses of compounds, please check out my video on calculating relative formula masses of compounds. It will put you through. So here we have 0.075 mole. Now that we have the mole of magnesium and the moles of hydrochloric acid, let's now go ahead and calculate the mole per coefficient ratio. Now, when we look at this equation, we can clearly see that the mole of magnesium in this case is 1, and the mole of the coefficient of magnesium in this case is 1, and the coefficient of hydrochloric acid is 2. So let's calculate the mole per coefficient ratio. So mole per coefficient ratio, mole per coefficient ratio. So what do we have? Now, the mole 0.05 for magnesium divided by the coefficient of magnesium is 1. The mole of hydrochloric acid 0.075, the coefficient is 2. So when we do this, we have here 0.05, that is the mole per coefficient ratio, and here we have 0.0375. Now, between these two values, which one is greater? Between these two values, you agree with me that 0.05 is the greater value. So this is the excess reagent. The one with the greater mole per coefficient ratio is the excess reagent. And the reactants with the lesser mole per coefficient ratio is the limiting reagent. So that is it. So from this, therefore, we can conclude that hydrochloric acid, HCl, is the limiting reagent. It has the lower mole per coefficient or the lesser mole per coefficient ratio. Now we can prove this otherwise. Let's look at it. Now in the alternative method, let's see what we can do now. Let's look at the equation again. So from this equation, we can see that 1 mole of magnesium reacts with how many moles of hydrochloric acid? It reacts with 2 moles of hydrochloric acid. So let's make use of this. Okay, so alternatively, we want to prove that the hydrochloric acid is actually the limiting reagent. So alternatively, let's see, from equation, 1 mole of magnesium reacts with 2 moles of hydrochloric acid. So remember, we calculated the number of moles of magnesium. It gave us 0.05 over here. So 0.05 mole of magnesium will react with or will need to react with, we multiply these two values, 0.05 by 2. So what do we have? Here we have 0.1 mole of HCl. So you can see that for the number of moles of magnesium, 0.05 mole, to completely react, it will require 0.1 mole of hydrochloric acid. But what is the mole of hydrochloric acid present? We can see that this is the number of mole of hydrochloric acid present, which is lesser than what is required for the magnesium to completely react with it. So because of this, therefore, we can then conclude that since only 0.075 moles of HCl is present, hence HCl is the limiting reagent or the limiting reactant. Now let's look at the B part of the question. What mass of the excess reactant was left at the end of the reaction? Remember, we've been able to determine that magnesium is the excess reactant. So let's see how we can determine the mass of the excess reactant that was left. So we are looking at the B part of the question. Now, for us to know the mass of the excess reactant that was left, we need to know the mass that reacted. We need to know the numbers of moles that reacted, in other words. And for us to do that, we need to use the equation of the reaction. Let's look at the equation once more. In the equation, we have 1 mole of magnesium reacting with 2 moles of hydrochloric acid. So let's see how we can make use of that. So we shall say from equation, 2 moles of hydrochloric acid, 2 moles of HCl reacts with 1 mole of magnesium. So 0.075 moles of HCl will react with 0.075 multiplied by 1 divided by 2. What does that give us? It gives us 0.0375 moles of magnesium. So in other words, this is the number of moles of magnesium that reacted with this number of moles of hydrochloric acid. So now that we know the number of moles of magnesium that reacted, we can calculate the number of moles that was left. So excess mole of magnesium, excess mole of magnesium. How do we calculate that? It will be equal to the moles of magnesium at start, moles of magnesium at the start, minus the moles of magnesium that reacted, minus moles of magnesium that reacted. Okay, so the mole of magnesium at the start, remember it was 0.05. So here we have 0.05 minus the mole that reacted, 0.0375. So if we perform that operation, we have 0.0125 moles of magnesium. Okay, now that we have the number of moles of magnesium that was left, we can conveniently calculate the mass that was left. We know that moles is equal to mass multiplied by molar mass. So mass of magnesium left, mass of Mg left is equal to, we have the moles, the excess moles, 0.0125 multiplied by the molar mass of magnesium, that is 24, and that gives us 0.3 grams of magnesium. So this is the mass that was left at the end of the reaction. Okay, so go ahead and try this exercise. In the reaction, you can see it. So pause the video and try this exercise. Once you're done, come back to the video. 40.0 grams of calcium is reacted with 6 grams of ethanoic acid. What is the limiting reactant? What mass of the excess reactant was left at the end of the reaction? Okay, so here we need to follow the same procedure we followed in the previous case. Okay, so let's see what you've done. Now, take note here we have 2 reactants. We have calcium and we have ethanoic acid. So let's begin by calculating the number of moles. So for the reactants, we have calcium, we have ethanoic acid. Okay, so what's the mass of calcium we have here? We can see 4.0 grams, and here we have 6 grams of ethanoic acid. So 4.0 grams, here we have 6 grams. These are the masses. Now moles. For moles, we divide the mass by the molar mass, 4.0 divided by 40. The molar mass of calcium is 40. Look it up on the periodic table. Ethanoic acid, if you calculate the molar mass of ethanoic acid, you're going to have 60. Like I said, if you have difficulties calculating molar masses or relative formula masses, make sure to check out my video on calculating relative formula masses. You would have it. So here what do we have? We have 0.1 mole, and here we have 0.1 mole as well. Now we need to calculate the mole per coefficients ratio. So the next thing we do is the mole per coefficients ratio. Coefficients ratio. Oh, here we have 6 divided by 60. That is that. So mole per coefficients ratio. Let's look at the equation once more. In the equation, we can see that the coefficient of calcium is 1 and the coefficient of ethanoic acid is 2. So in the mole per coefficient ratio for calcium, we have 0.1 divided by 1, that gives us 0.1. Here we have 0.1, that is for ethanoic acid, divided by 2, and that gives us 0.05. So we can see that 0.1 is greater than 0.05. So calcium is the excess reagent or excess reactant. Excess reactant. While the ethanoic acid is the limiting reactant. It has the lesser mole per coefficients ratio. Limiting reactant. So that is it. This therefore means that the amount of products formed in this reaction depends on the ethanoic acid because it is the limiting reactant. It will get used up first. Okay, now if we look at the second part of the question, what mass of the excess reactant was left at the end of the reaction? Now, for us to know the mass of excess reactant that was left, we need to know the number of moles of the excess reactants that reacted. And if we look at the equation for the reaction again, we can see that 2 moles of ethanoic acid reacted with 1 mole of calcium. So we need to make use of that. So let's look at the B part of the question. B. So from equation we have 2 moles of ethanoic acid reacts with 1 mole of calcium. So 0.1 mole. Remember the number of mole of ethanoic acid we calculated was 0.1. So that is where we got this 0.1 from. So 0.1 mole of ethanoic acid reacts with we take 0.1 divided by 2 and we have 0.05 mole of calcium. So that is the number of mole of calcium that reacted. Now, just like in the previous example, if we want to get the excess mole of calcium, so excess mole of calcium, it will be equal to the mole of calcium we had at the start, that is 0.1, minus the moles that reacted, 0.05, and that gives us 0.05 mole of calcium. Now that we have the number of moles of calcium that was left, we can conveniently calculate the mass by multiplying the moles by the molar mass. So we have 0.05 multiplied by the molar mass of calcium is 40, and that gives us 2 grams of calcium. So this is the mass of calcium that was left at the end of the reaction. Okay, go ahead and try this next exercise. That is the last. So it reads, 10 grams of chlorine gas is reacted with a solution containing 25 grams of sodium bromide. Calculate the mass of bromine formed. Calculate the mass of bromine formed. The equation for the reaction is given. So pause the video and try to see if you can get this. Okay, Now let's see what you've done. Over here, what do we have? We have the reactants, chlorine and sodium bromide. And the products, we have sodium chloride and bromine. So remember, we need to calculate the mass of bromine that is formed. And bromine is the product. Now take note, we have two reactants. And it is the limiting reactants that will determine the mass of bromine formed. Remember the example we used, the case of the fuel and the engine of the car. When the fuel stops or when the fuel is finished, the car stops moving. So when the limiting reactant here finishes, the reaction stops. So the mass of bromine that is produced will depend on the limiting reactant. This means that we need to first of all determine the limiting reagents between chlorine and sodium bromide. So how do we do it? Let's see. Okay, so here we have the reactants. For the reactants, we have chlorine and we have sodium bromide. Good. So the masses for chlorine, the mass is 10.0 grams. For sodium bromide, the mass is 25 grams. So let's calculate the moles. Moles, here we have 10.0 divided by, now chlorine, one atom of chlorine has a relative atomic mass of 35.5, but here we are dealing with the chlorine molecule, so we multiply that value by 2, we have 71, and this gives us 0.14 moles, 0.14 moles. And here we have 25 divided by the molar mass of sodium bromide is 103. This gives us 0.243 moles. Okay, now that we have the moles, let's look at the coefficient. The coefficient of chlorine here is 1. The coefficient of sodium bromide is 2. So let's calculate the mole per coefficient ratio. So mole per coefficient ratio. Here we would have 0.14 divided by 1, that gives us 0.14, and over here we have 0.243 divided by 2, that gives us 0.1215. Now between these two values, which one is larger? We can see that 0.14 is greater than 0.1215. So here we have the excess reagent or excess reactants, and here we have the limiting. So sodium bromide is the limiting reagent. Now that we know the limiting reagent, it means what is going to determine the mass of bromine formed in this reaction is the sodium bromide. So we are going to use that to determine the mass of bromine. And so let's see, from equation, we can see that 2 moles of sodium bromide forms how many moles of bromine? It forms 1 mole of bromine. We are going to make use of that. So let's see, from equation, 2 moles of sodium bromide forms 1 mole of bromine. If that be the case, therefore 0.243 moles of sodium bromide will form, we have 0.243 divided by 2, and this gives us 0.1215 moles of bromine. So this is the number of moles of bromine that is formed. Now that we know the number of moles of bromine formed, we can conveniently calculate the mass. We know that mass is equal to number of moles multiplied by molar mass. So we have number of moles 0.1215 multiplied by the molar mass of the bromine molecule Br2. Bromine atom has a relative atomic mass of 80. If you multiply that by 2, you have 160. So 1 multiplied by 160. What do we have? We have 19.44 grams of bromine. So this is the mass of bromine that is formed in the reaction. So this is how you can determine the limiting and excess reagents in a chemical reaction, and how you can calculate the mass of the excess reactants that is left in a chemical reaction. Hope you found this video interesting. Hope you found this video helpful. Now remember to leave your comments in the comments section below. If you've not yet subscribed to my YouTube channel, go ahead, hit the subscribe button and turn on the notification button, so each time I upload a new video, you will be notified. And remember to like the video. Thank you so much and have a great time. It was NN Fabien. Bye bye.